Dear students, in today's class, we are going to see few more numericals on force convection. So, you will find one numerical in front of you. We are trying to interpret the data from the numerical. Now just read the statement. 65 per kg minute of water. So water is given as fluid and its mass flow rate is given. Kg means mass and minute means time. So it is m dot 65 kg per minute. So just 1 minute. 65 kg per minute means 65 divided by 60. That comes around 1.0833 kg per second. Convert minute, hour in second. If mass flow rate is given, volume flow rate is given, or velocity is given, it is hint to understand this problem is of force convection. So in this problem, mass flow rate is given. So it is a force convection. Heated from 30 to 60 degrees Celsius means T1 is equal to 30 degrees Celsius and T2 is equal to 60 degrees Celsius. This means this problem belongs to internal flow because entry temperature is given and exit temperature is given. Is passing through a rectangular duct of 3 cm by 2 cm. So how to draw the rectangular duct? Duct means channel. Just like circular tube, but what is the difference between circular tube and rectangular tube? Duct cross section. There is a circle and here is a rectangle. So 3 cm by 2 cm. So let's say this is 2 cm, this is 3 cm. The duct is heated by condensing the steam on the outer surface. On this outer surface, the steam gets condensed. So what is the condensing steam temperature? That is Ts. Outer surface means duct ka outer wall on which there is a condensing steam. So what is the surface temperature? Steam condenses at 100 degrees Celsius at atmospheric pressure. So Ts is by default 100 degrees Celsius. Remember student, they have not given 100 degrees Celsius, but they have given the word condensing the steam. So steam condenses at 100 degrees Celsius on the wall. So Ts is equal to 100. Find out the length of the duct required. Okay. And what is the given thing? These are the properties of water given to you. Correlation is given to you. But remember, here one is given for turbulent flow and other is given for laminar flow. So you have to make a choice here. And required answers we need to find out the length of the duct. So if you recall, what is the procedure for force convection? The first step is LC, second step is Reynolds number, third step is Prandtl number, fourth step is Nusselt number, fifth step is H, sixth step is Q, seventh step is dt by dt, but that is not mandatory. If it is asked, only you need to use. Number 8 is nothing but L or exit temperature T2. So I think in this case, this is not asked. That is rate of heating or cooling is not asked to you. What is asked to you? Length. Okay. Even exit temperature is also given. So this is our target. This is given to you. So we need to go up to 6th step and from there you need to jump to 8th step. Okay. So we'll go to the solution. Solution. What is LC? LC for internal flow through a channel, either it is a circular tube, either it is a triangular tube, either it is a rectangular tube, either it is a square tube. The formula for internal flow is LC is 4 into area of cross section upon perimeter. What is 4 into area of cross section? This is the cross sectional area. So 3 centimeter and 2 centimeter. So 3 into 2. So 0.03 into 0.02. Convert in meter, centimeter, millimeter. You need to convert in meter upon perimeter. What is perimeter of a rectangle? 0.03 plus 0.02 into 2. So this answer comes out to be 0.024 meter, 0.024 meter. So that is LC. Now the next step is to find out the Reynolds number. Rho V LC by mu. This is the formula. Second formula is V LC by nu. What is the property given? Dynamic viscosity is given, use the first formula. Kinematic viscosity is given, use the second formula. What is given in the property? Mu is given. So definitely we need to use the first formula. But there is one problem: density, velocity and characteristic length. Density is given, but velocity is not there in the problem. Instead of velocity, they have given mass flow rate, m dot, 65 kg per minute, that you have converted as 1.0833 kg per second. So how to use the mass flow rate here? Because velocity is unknown. So what to do? We have seen such problem earlier. M dot is equal to rho into area of cross section into velocity. Okay. So rho into V I will combine together. Rho into V I will combine together. So it becomes m dot upon AC. So what is m dot? M dot is given as 1.0833. 1.0833 divided by AC. AC means area of cross section. It is how much? 0.03 into 0.02. If I will solve it, the product of rho V is coming as 1805.5. Now I will calculate easily Reynolds number. I got this circle value, that is collective value of density and velocity product. So rho V is 1805.5 into LC. How much is LC? 0.024. And how much is mu? You can see the property table, 7.65 into 10 raised to minus 4. Okay, the answers of Reynolds number turn out to be 56643.13. Now the next step. What is the next step after Reynolds number? Prandtl number. Let's check whether it is given directly. No, Prandtl number is not there in the property table anywhere. So we need to use the formula for Prandtl number to calculate it. Mu Cp by K is equal to nu by alpha. Depending on the data given, you have to select the formula. So I think mu is given, nu is not given. So first formula is used. So I will do it. Prandtl number mu. What is mu? 7.65 into 10 raised to minus 4. What is Cp? It is given in kilojoule. Convert it in joule. So it is 4174. Multiply by 1000. No? 4174 divided by K. What is thermal conductivity? K for water? 0.623. 0.623. So Prandtl number turns out to be 5.1253. 5.1253. I think I got now Reynolds number and Prandtl number. What is the next step? Nusselt number. But for Nusselt number, they have given two correlations to us. This is first for turbulent flow and laminar flow. So before going to that Nusselt number correlation, I need to find out whether the flow is turbulent flow or laminar flow. So how to get that? Just check the value of Reynolds number. Reynolds number value is 56,643 for flow through channel or flow through duct. If the Reynolds number value is greater than 4,000, the flow becomes which flow? Turbulent flow. And if the Reynolds number value is less than 2000, the flow becomes laminar flow. In this case, it is greater than 4000, that is 56,643. So it is turbulent flow. So for turbulent flow, what is the correlation? This one. Okay. You have to discard this because flow is not laminar. So let's see it. Nusselt number is equal to 0.023 RE raised to 0.8, PR raised to 0.4. Okay, just put the values. 0.023 RE. RE is 56,643.13 raised to 0.8. Then Prandtl number 5.1253 raised to 0.4. If I will calculate it, it comes around 280.63. Now, what is the next step from Nusselt number? I think these 4 steps are over. So what is the next step? To get H value. To get H value. So H formula is NUK by LC. So what is NU? 280.63. What is K? What is K? 0.623. And what is LC? 0.024. 0.024. The answer of H turns out to be 7284.71 watt per meter square Kelvin. So this is H. Now what is the next step? To get the value of heat transfer rate. Q is equal to, by Newton's law of cooling, H8 Ts minus T infinity. Okay. So in this case I know H, I know Ts, T infinity is unknown, area is unknown. So we'll go one by one. What is area? Area is, for a duct, the formula of area is perimeter into L. So what is perimeter? Perimeter is 3 plus 2 into 2. 3 centimeter means 0.03 plus 0.02 meter में करो into 2. This is perimeter. Okay, this is perimeter into L, and L is, I think, not given in the problem. Same thing is asked to you, na? So keep as it is, L. So okay, so what it becomes? Just I will check the calculator. Okay, 0.03 plus 0.02 into 2, it is 0.1. So 0.1 L. This answer is turns out to be 0.1 in terms of L. Okay, 0.1 L. And what is T infinity? T infinity is entry and exit average temperature in case of flow through duct. So T1 plus T2 upon 2. What is T1? 30 and T2 is 60. So 30 plus 60 divided by 2, it comes around 45 degrees Celsius. So T infinity is there. So what is Q? H 7284.71 into 0.1 L into Ts 100. Condensing steam means 100 degrees Celsius minus 45. If I will solve it, the answer of Q is coming as 40,065.90 L. We will just check out whether it is right or wrong. Once again, yeah, it's correct. So Q, this is, I will give this number as equation 1. Okay, now I will move to the next. In this problem, in this case, Q is also unknown and L is also unknown. So we need to try Q by another formula. So what is another formula for internal flow? Q is equal to, if the fluid is flowing through a channel, there is another formula for Q, because heat is gained by the fluid and fluid is flowing through the tube. So with a mass flow rate m dot. So m dot Cp T2 minus T1. This is another formula for flow through channel. Okay, so what is m dot? M dot is given 1.0833 kg per second. The second में चाहिए 1.0833. What is Cp? What is Cp of water? It is 4.0 174, but it requires in joule, na? So 4174 multiply by 1000. And what is T2? I think it is 60 minus 30. So if I will calculate, the answer of Q is coming as 135650, 135650.82 watt. This is equation 2. Now I got the value of Q. So equating 1 and 2, I will get 465.990 is equal to 135650.82. Okay, if I will solve this, this is L. So if I will solve this, the answer of L comes around 3.38, 3.3856 meter. Okay, so this is a required answer. So with this, we have finished the first problem for today. Now we'll move to the next problem. Problem number 35. Okay, but correlation is missing in this problem, that I will add. I have copy pasted it for you just for a reference sake. Okay, is it visible, students? Hopefully yes. Now we are going to solve this particular problem. You help me to interpret the data. Let's start. Okay, in this problem one thing is missing that I will add. Please note it down. Nusselt number is given as 0.023 Re raised to 0.8, Prandtl number raised to 0.4. You have to make use of this correlation. Okay, ठीक है. This is not given, but in the exam it will not happen. This will come. Okay, later. Now, water at 50 degrees Celsius. Water, the fluid is water. At 50 degrees Celsius, enter 1.5 centimeter diameter and 3 meter long tube. So it enters through the tube, means it is again a channel flow or duct flow. And duct is of circular cross section, means it's a tube. So there is the entry temperature, there is the exit temperature. So what is T1 given? Calculate the heat transfer coefficient and total amount of heat transferred if the water exit temperature is 70 and water at 50 degrees Celsius enters. 50 enters and exit temperature is 70. So T1 is 50 degrees Celsius and T2 is 70 degrees Celsius. What is the diameter of the tube? So D is given as 1.5 centimeter. So that means 0.015 meter. Okay. 3 meter long length. So length of the tube is also given. In last problem length was unknown. Now in this case length was given. Okay, with a velocity. Here velocity is given. So our job is simplified. 1.5 meter per second. Velocity is given, means the problem belongs to post convection. If mass flow rate, volume flow rate, velocity is given, problem belongs to post convection. यहाँ velocity दी है. The tube wall is maintained at 100 degrees Celsius. So Ts is 100 degrees Celsius. Calculate the heat transfer coefficient. So what they have asked you, required, they have asked number 1 H and total amount of heat transferred, so Q, if the water exit temperature is 70, that I have already mentioned. Okay, and properties of water are given that we have to use. So two things they have asked. convective heat transfer coefficient H, and second heat transfer rate. Now let's begin with the process. I am outlining the process here. How to solve the problem of forced convection? पहले तो हमने ये समझ लिया कि वेलोसिटी मेंशन है, मीन्स ये प्रॉब्लम फोर्स कन्वेक्शन का है। तो ये समझने के बाद प्रोसीजर आउटलाइन करेंगे। पहला स्टेप क्या होता है बच्चों? LCE. Second step to find out Reynolds number. Third step to find out Prandtl number. Fourth step is to find out Nusselt number by correlation. Fifth step is to find out H. Sixth step is to find out Q. Seventh step is to find out dt by dt. And eighth step is to find out L, or exit temperature T2. But in this case, they have not asked rate of heating or rate of cooling. They have not asked length or exit temperature T2, because everything is known to you. They have asked H and Q, means we have to go up to only fifth and sixth step. Okay. Now we are going to use these steps to solve the problem. Let's start with LC. For flow through duct, and duct may be of any cross section. It may be rectangular, it may be a triangular, it may be a circular, means it's a tube. Formula is 4AC upon P. So what is the area of cross section? This is the cross sectional area. So 4 into pi by 4 d square divided by, what is the perimeter for this? Perimeter means this. It's a tube, na? So pi d. Pi d. I think d get cancelled, pi get cancelled, 4 get cancelled. So it remains only d. And that comes around, d is given 0.015 meter. Centimeter nahi chalega, millimeter nahi chalega. Convert it in meter. So it is 0.015 meter. So LC is over. Now next step is to go for Reynolds number. What is Reynolds number? Rho V LC by mu, or V LC by nu. Which data is given? Depending on that, decide the formula. I think mu is given. Okay. So I need to go with first formula. Rho is 1000. Rho is 1000. Velocity is given as 1.5. LC is 0.015. And mu is given as 7.65 into 10 raised to minus 4. So answer of Reynolds number turns around, just 1 minute, I have already calculated it for you. It is coming at 29,411.76. Okay. Now the next step is to calculate Prandtl number. Whether it is given directly, I think, see the properties of water, no Prandtl number mentioned. So naturally you have to go for the formula. Mu Cp by K. This is the first formula. Second formula is mu by alpha. I think the first is going to be used because mu value is mentioned. So what is Prandtl number? 7.65 is mu into 10 raised to minus 4. What is Cp? Cp is 4.187. किलोजूल में है, जूल में करना पड़ेगा आपको. So 4187. I am writing here. It must be in joule per kg Kelvin. Kilojoule नहीं चलेगा. Okay. And divided by K. What is the value of K? K is given as 0.60. 0.60. So Prandtl number turns out to be 5.3384. 5.3384. Okay. Now what next? After getting Reynolds number and Prandtl number, there is a Nusselt number now. So how to get Nusselt number? By correlation. Correlation is given only one, so we need not to select it. It's only one, so we have to use same. 0.023, RE raised to 0.8, PR raised to 0.4. Just put the values. 0.023, Reynolds number 29411.76 raised to 0.8, Prandtl number 5.3384 raised to 0.4. If I will calculate it, Nusselt number turns out to be 168.85. Okay, 106 dimensionless number, so no unit. Now from Nusselt number, how to get H? It is Nu K by LC. So what is Nu? 168.85. What is K? K value is 0.60 given. You see the property. And LC is how much? LC is given as calculated as 0.015. 0.015. Look at here. If I will put, I will get the value of H as 6754.13 watt per meter square Kelvin. So I think this is asked to you, so it becomes answer number 1. What is next? They have asked you the value of Q. So how to get Q? Q is equal to, by Newton's law of cooling, HATS minus, there are two formulas of Q, but first is always Newton's law of cooling, HATS minus T infinity. So what is unknown here? I think area. So what is area for flow through duct or channel or pipe? Area is perimeter into length. So what is perimeter? Pi d into L. Okay. So if I will calculate pi into d, d is how much? 0.015. And what is L? I think length is given as 3 meter. So what is the area? The area answer is, just 1 minute, I will do it for you. Pi into 0.015 into 3, it comes around 0.1413. 0.1413 meter square. So if I will put it here, Q is equal to H is 6754.13 into area is 0.1413 into TS. Surface temperature is given as 100, I think. Look at here. TS is 100 minus, what is T infinity? T infinity is calculated as average of entry plus exit. So 50 plus 70 divided by 2. Okay. And if you solve this, the answer of Q comes as, it's straightforward. Take an average and then substitute it and calculate. The value of Q comes around 38193.70 watt. Okay. So this is the end of this problem. Okay. Okay. Now we'll go to the next problem. Just I am taking photo of it for your reference. This copy, I'm coming back to PPT and pasting it here for you. Okay, students. Let's help me to interpret the data for this problem. Okay, let's begin. Data. Water at 20 degrees Celsius is to be heated by passing it through the tube. Tube means circular cross section. Means here is the entry T1, exit temperature T2, and water at 20. So T1 is equal to 20 degrees Celsius. It's passed through the tube. Surface of the tube is maintained at 90. So TS is how much? 90 degrees Celsius. Diameter of the tube is given as 4 centimeters. So 4 centimeter means 0.04 meter. Okay. While its length is 9 meter. I think just like previous problem. Okay. Find the mass flow rate. 9. Something is different here. They have asked now here mass flow rate. So required answer is m dot. And exit temperature is given as 60 degrees Celsius. T2 is 60 degrees Celsius. Okay. And they have listed properties of water for us to calculate dimensionless numbers, and Nusselt number, only one correlation is given. So we need not to go for choice. Only one is there, you have to use it directly. But they have asked here m dot. So don't panic, students. Follow the process. Okay, so we'll go for solution. Let's recall the process. As the mass flow rate is asked earlier, what is the hint I have given to understand the problem belongs to natural or forced convection? mass flow rate, velocity, volume flow rate. If such things are given, the problem belongs to force convection. In this problem, no volume flow rate. In this problem, no velocity is mentioned, but they have mentioned to calculate mass flow rate. So that means this problem is definitely belongs to force convection. So what is the process? First is LC, second is RE, third is PR, fourth is Nusselt number, fifth is H, sixth is Q, seventh is dt by dt, and eighth is L or T2. I think in this problem dt by dt is not asked, length is given, and exit temperature T2 is also given. So I think we need to go up to only step number 6, okay, to solve the problem. So let's go one by one. I will go to the solution. Let's start. First step is LC. What is LC? For flow through channel, it may be a rectangular, it may be a triangular, it may be a square duct, it may be a circular tube. The formula is 4 area of cross section upon P. 4. What is the area of cross section? This is a cross sectional area. Okay. So it is pi by 4 d square. And what is the perimeter? Perimeter is along the cross section. So this length of this circle. So it is a perimeter. It is pi d. So I think dd get cancelled, pi get cancelled, 4 get cancelled. So it becomes only d. So what is LC? LC is diameter 0.04 meter. So LC 4. Now next step to get the Reynolds number. What is the Reynolds number? Rho VLC by mu or VLC by nu. But in this problem, velocity is not mentioned. Nu is given. Nu is given as 0.62 into 10 raised to minus 6. Okay, and velocity is not mentioned. So I will discard the first formula because nu is given. I will use the second formula. So Reynolds number, but velocity is also unknown. So what to do? You know it. How to do? M dot is equal to rho area of cross section into velocity. So what is velocity? Just 1 minute. What is velocity then? Just 1 minute. There is an issue of internet connectivity. Hopefully it will be right now. Velocity is equal to M dot upon rho AC. Let's check out the things are given or not. So M dot is also unknown. I will keep as it is. Okay. Upon rho is how much? 995. It is given. See, 995. 995 into AC is how much? AC is cross sectional area pi by 4 d square. See the cross sectional area, this one. Pi by 4 d square. So it is pi by 4.04 square. So what is velocity? Just 1 minute. I have done the calculations for you already. Yes, I will check it out. It comes around, just 1 minute. 0.7997 0.7997 m dot. This is the answer of velocity. Now I will put this in the second formula of Reynolds number. क्योंकि nu is given, mu is not given. So VLC upon nu, it is 0.7997 m dot upon nu. What is nu? 0.62 into 10 raised to minus 6. 0.62 into 10 raised to minus 6. So if I will get this value, Reynolds number comes around, yes, I will again calculate for you. 1 to, just 1 minute, something is Please see here. I need to check the answers. Just give me a minute, student. 0.7997 m dot. Okay. So if I am putting the velocity there, so Reynolds number comes around, velocity is 0.7997 m dot. Okay. LC value I have not substituted here, that is remaining. That's why the mistake is happening. What is LC? LC is diameter 0.04. 0.04. So it comes around, Reynolds number comes around as, just 1 minute, 0.7997 into 0.04 divided by 0.62 10 raised to minus 6. It comes around 51,593. 51,593 point. Just wait. My answer is coming in. Okay, 51,593.54. This is the value of Reynolds number. Now next, what is the next step to get Prandtl number? There are two formulae, mu Cp by K, and second formula is nu by alpha. But okay, problem is mu is given but alpha is not given. In this case, mu is unknown. So now here is the problem. How to take the decision? Which formula I need to choose? Nu is given, alpha is not given. Mu is not given. So how to do it? Still I am going to use the first formula because I can calculate mu from nu. How? Nu is given as mu by rho. Mu by rho. Kinematic viscosity is equal to dynamics viscosity upon density. So what is mu? Nu into rho. So what is nu? Nu is given as 0.62 into 10 raised to minus 6 and density is given as 995. So what is the answer of mu, students? The answer of mu as, just I will do it for you, 0.62 10 raised to minus 6 into 995, that comes around 6.169 into 10 raised to minus 4 kg per meter second or Newton second per meter square. Any unit you can write for mu. This is dynamic viscosity. So I got now the value of mu and therefore Prandtl number becomes mu 6.169. अभी अभी calculate किया 10 raised to minus 4. What is Cp? Look at the data table. Cp is 4.1874. So convert it in joule. 4174 किलोजूल में दिया है ना, convert in joule. So multiply by 1000. 4174 divided by K. What is K? K comes at 0.64. So 0.64. So it comes around, Prandtl number is coming as 4.0233. 4.0233. What is the next step? Nusselt number. So Nusselt number is given as, I think they have given only one correlation. So you can use directly 0.023 RE raised to 0.8 PR raised to 0.4. Put the values. 0.023 Reynolds number. How much is the Reynolds number? it is something, it is in terms of m dot, sorry, because this m dot is still unknown. M dot is unknown and that is asked to calculate. Okay, so what is the Reynolds number? 51593.54 m dot raised to 0 0.8. What is Prandtl number? 4.0233 raised to 0.4. Okay, this is the equation. So if I will calculate it, okay, if I will calculate it, the answer is coming as 236.41 m dot raised to 0.8, m dot raised to 0.8. This is the answer coming. Keep as it is, because you are saying, sir, m dot is unknown, still we are unable to calculate Nusselt number. Because final answer we require is m dot. Now next, what is after Nusselt number? H. H is equal to NUK by LC. So what is NU? Just now calculated in terms of m dot. 236.41. Okay, 236.41 into K. How much is the K? 0.64. And what is LC calculated? LC is calculated as 0.04. 0.04. Okay, this is m dot raised to 0.8. Okay. So answer comes around, the answer of H comes around 3782.60 m dot raised to 0.8. I am keeping as it is. Okay, H is also over. Now next formula is Q. By Newton's law of cooling, H A Ts minus T infinity. Okay, so in this formula, H is known to you, area Ts is known to you, T infinity is T1 and T2 is given. So this is unknown right now. I will calculate what is the area for the tube. For flow through channel, it is perimeter into length. So it is pi dl. So let's do it, pi into d. What is d? 0.04. And what is the L? 9. 0.04 into 9. So area comes around pi into 0.04 into 9. It comes around 1.1309. 1.1309 meter square. Okay. T infinity. How much it comes? T infinity is entry plus exit average. So T1 plus T2 upon 2. It is 20 plus 60. 20 plus 60 upon 2, I think it is 40 degrees Celsius. 60 plus 20 is 80. 80 divided by 2 is 40 degrees Celsius. So let's put the values. Q is equal to H 3782.60 m dot raised to 0.8 into, this is H, area is 1.1309 and into Ts minus T infinity. Ts is, how much is Ts? Let's check. Ts is 90 given. 90 minus 40. If I will solve this, the answer of Q comes out to be 213900, 213900.99 m dot raised to 0.8. M dot is carried forward because that is only the unknown. Okay, this I am putting as equation 1. So let's try to find out, because here I don't know Q, I don't know m dot. So find out Q by another method. There is one another way to calculate Q. Q is equal to, for internal flow, internal fluid flow through the channel, there is another formula of Q. It is m dot Cp T2 minus T1. M dot Cp T2 minus T1. So what is m dot? That is unknown. What is Cp? Put it in joule, joule per kg Kelvin. So it is 4174. What is T2? I think T2 is 60, and what is T1? It is 20. So Q becomes 166960 m dot. Okay, it is again unknown m dot. This is another Q, and this is equation number 2. Now equating equation 1 and 2, because both are Q's. So you can equate them. So right hand sides are equal 213900 213900.99 m dot raised to 0.8 is equal to right hand side of second equation 166960 m dot, and if I will calculate it, it comes around, if I will solve this equation, m dot comes around 3.4514 kg per second. Solve above equation, you will get this answer. Okay, so students, that's it about force convection. In the next lecture we are going to see remaining problems of natural convection. Thank you for today.